All right, here we are. We're trying to use the second part of the fundamental theorem of calculus, and we're using this to do some integrals. On our first integral, here we are. I'm going to switch to black. Immediately, when I work this out, I think we can just jump right to equals. There's nothing crazy about this integral, and we are going to truly cold call here. And let's see. 13. I assume it's JJ, but I could be wrong. It could be Isha. Who's 13? Oh, okay. JJ, what's your first step on this integral? One more time? What do you mean find dx? Anybody want to help argue that? I think you have the right idea in mind, but the right idea is not the one that came out of your mouth. I don't find the derivative. Let's find the antiderivative. How do I anti-differentiate x squared? Add 1 to the exponent, so it becomes an x cubed. Anything else I need to do? Divide by the new exponent, so it's over 3. And then this part, I only saw one group include it, and I think it was Abigail. Were you on the backboard? Okay. Did we talk about this yesterday? I'm going to include this some more again. Plus C is really there. Now, this is the first time, and maybe the only time that we'll write this for now, but I want to really talk about why we don't write it normally. Okay. With this notation, what I would strongly recommend, because it's how I'm going to do it every time, and it's how you should do it, it's how AP graders are going to be looking for it as well. What numbers go on this wonderful vertical bar? Number 3. I don't know who number 3 is. Okay, Leanne, what do you want to put here? 3 to 5. Fantastic. All right, and it feels a little bit too impersonal today, and I don't know why. It usually doesn't bother me. But instead of just calling you random numbers, I'm actually going to call your name. Does it feel too impersonal to you guys? Fair. I got both answers. I'm fine with it. All right, so let's check it out. Number Bea. Oh, you're in a different spot today. You were there yesterday too. What do I do now? So love it. And I'm just going to make sure you guys don't have to write this, but it might help if you need a reminder. What is this? So, I love the Sean's fix. Cap F, right? This is my antiderivative. So now I'm going to do exactly like Bea said. We're going to do f of 5, and I'll go ahead and write this out. F of 5 minus, what am I going to subtract from this? F of 3. Now, you don't physically need to write this every time, but I do want to look through this and just see what happens. Off the top of your head, can you guys tell me 5 cubed? 125, so over 3. Because over 3 here. Plus C, right? Like, I don't know what it is. Minus, and then I want you guys to help me find my fatal flaw that makes this weird. What's F of 3? 27 over 3. Now, you may be tempted to simplify it. I'm going to suggest we don't. I have made a crucial error on the board. I want you to turn talk with your neighbor for like 30 seconds. Can you find what I've done wrong? Not 30 seconds. But no, you're good. Like, it's 30 seconds is the bottom end. It's such a subtle change, but it's going to make a huge difference. What's my mistake? Parentheses. Now, where am I missing parentheses that are needed for this problem? This part. If I write this, I've not really subtracted off all of f of 3, have I? Like, I've subtracted this number and then I added c. These parentheses make a world of difference. And like I said a minute ago, we're not going to use c every time, but I want us to see why we don't. So let's just rearrange stuff. I have 125 thirds, and I'm just going to put numbers next to numbers. And I hate this choice in hindsight. Okay, what else do I have here that I haven't written yet? Plus C. Anything else? Minus C. Is this same thing where I add the c and subtract the c going to happen every single integral that we ever do? Which means on every subsequent integral that we do, I don't mind whether we show this or not, but there was one group yesterday that really truly identified that, hey, look, these c's should be here, and they fall out of the problem. These are gone, and I don't remember if I said it, but I advised, in my head at least, to keep this 27 over 3 instead of changing to 9, because we have to subtract it. What's 125 minus 27? 98. And we're over 3, and c and minus c, they're done. Boom. We have it. Okay. Should we learn, and have we learned, to integrate on our calculators already? If not, that's all right. Grab your calculator for me real quick. We're going to learn the way to double check. Now, I just want to remind you guys, I know I have a pretty good idea of where all you guys are mathematically, like on your own. If you can get answers because you have a calculator, you might do well on like half the AP test, but doing well on half of it is not going to get you what we need. Cool. So if we want to do an integral, how do I get there? I'm going to do some calc, F3. And then integrate, I believe, is 2. And it might say integral. Okay, so I hit it and it gives me this. Is that true? Wonderful. Okay, what do we have to put in here? What is f of x, the function that we're integrating, sorry? X squared. Now, I don't remember the order, and I'm going to try real hard. Where are we going? What are our bounds? We're going to see if this works. The upper and lower limit of integration. 3 and 5. So if we're wrong, we'll fix it. But I think it has to be 3, 5, and then we could write dx, but we don't have to. We just need to tell what variable we're using. This is with respect to what? X. I think this is going to give it to us. If you get error, let me know. Let's put the x first. And I just can't remember which way it goes. I don't have a calculator up in front of me. X squared. X, 3, 5. $98.3, you must have yours set on approximate. 98.3 or 98 thirds. And somebody who has yours on approximate probably says 32.6 or 30. Cool. Awesome. You can use them to check answers, but I want to be very cautious with it. When we get to doing integrals that maybe don't have the bounds on them, your calculator will still find them, but it's not going to likely find the version that you find because there's different techniques that you can do to get integrals. We're going to go with the easier ones. Your calculator might use more sophisticated techniques that we're not going to cover in here. The answers may not look the same, but they should be equivalent, and that's hard to tell sometimes. Okay, this integral. Any harder? Do we want to work through this one as a group as well, or just leave this as an example that you guys can complete in your notes if you want it? As a big group or a small group? Okay, the race is on. I need you to show all of your work as clearly as possible, such that any person in this class could pick it up and I could ask them what is happening on this step, and we could all identify it. I want you to know I might grab somebody or multiple somebody's notebooks, put them up on the board, and point to a step and say, what are they doing here? Show clear work with these. I'm going to give you guys like 2 minutes-ish. Anybody want to try to do it with the limit of the Riemann sums instead? Okay. So when I'm looking at this, thank you for your honesty, by the way. I see the integral of a difference is the difference of the integrals. So I'm not going to physically split this up like we could. We could. I don't want to. I'm just going to integrate it right away. I'm going to find the antiderivative. 4x cubed. What happens with this exponent? Add 1. It becomes x to the 4th, and then we divide by 4. 4x to the 4th over 4 is just x to the 4th. This exponent doesn't exist yet. I mean, it does. We don't write it. What is it? So when we add 1 to it, we're going to get x squared. So we have 6x squared divided by 2. Can we just call it 3x squared? Have I lost you? Okay. What about this one? 5x. And I'm going to ask a really odd sounding question. What's the power of x connected to this 5? Love that answer. X to the 0. Okay. Add 1, divide by 1, and we get the 5x that we're expecting. We have this lovely antiderivative. What goes here? 1 and 2. Now, when you're working these problems, I don't really mind if I see f of 2 minus f of 1. Like, in reality, I don't mind if I see it, but I need you to make sure that if you're not going to show it, do scratch work somewhere, because I'm going to make mistakes in mental math. You're going to make mistakes in mental math. We'll just try to minimize those. So let's see if I can not make a mistake in mental math. 2 to the 4th is 16. Minus, this is going to turn into a 12. So I'm at 16 minus 12 is 4 plus 10. I think that this is 14. Minus, I'm going to do the same thing. 1 to the 4th is 1. Minus 3 is negative 2. Plus 5 is 3. And look at that. I got the same answer that a lot of you guys got, and we have 11. Okay. These problems are nice. What did we really just find? Like, give me a way or one of the ways that we can interpret what we just found. The area where? What area? Under the curve of the function. So if we were to graph this, and I can graph it if you guys want, it's going to be a cubic function. I don't know how bendy it is. I can't graph them well in my head. But we're going to get an area of 11 when we go from 1 to 2. Done. Should we do another one like this, or should we look at a fundamental part 1 problem? Let's do one more like this. All right. Ooh. All right. I don't have another one just like this, but we'll make it up. Okay, last one. This is C. I want you guys... Ooh, should we do this one up on the board? Let's do this one on the board. You can take your notebook and put it in the notes if you want to. We'll go... I'm okay with you guys picking your groups. I will get the random group generators thing set up, so we'll do this. But find 2 of your classmates and group up. We'll do a group on this board, 2 groups on the middle board, and a group on the far board. Cool. Ah, that would have been cool. All right. Hey, this is a neat problem. We did the odd APs already, right? Cool. All right. I want you guys to find for me talking with one another. I want to hear good conversation. You can ask me questions, but I'm not going to answer. I want you to do the integral from -3 to 5 of, let's see, our integrand. We're doing -3 to 5, and I lost my problem, sorry. 3 minus x squared dx. Cool. Sean. Awesome. Do it to it. You can on this problem. The work itself isn't terrible, I don't think, and I hope you guys agree with that. Where did you catch? If you're gonna make a mistake on a problem like this, where is it gonna happen? So I didn't hear what you said. I heard sorry. The antiderivative. So that's a reasonable spot. Not what I was expecting to hear, but that's the harder spot to do. Where am I concerned about you making algebra mistakes? The subtraction part, right? Like, it's ugly. You're going to make mistakes, just so you know. If you do all your scratch work off on the side every single time, you might be able to avoid that. But if we're being real, do you guys always do all your scratch work, or do you do some mental math? Like, everybody does some mental math. Everybody's going to make a mistake. Try to minimize those mistakes. Now, I like these answers. You guys all got the right answers. It's awesome. Is this region primarily below or above the curve? Above. Why? Why do you say that? There was a lot of confidence on the first answer. Talk with your neighbors. I want to know, why do we think that this curve is, or the region is above the curve? Talk it out. 30 seconds. I'm going to call, or a minute, maybe. Why above the curve? The first part of the fundamental theorem, and all of these were FTC part 2s. Let's knock out some FTC's part 1. So, new example, and I think I want to try to do 1 or 2 together, and then I'm going to have you guys get up and go back to the boards. I'm also going to go get a bunch of black markers, because the red markers are really hard to erase for some reason. But let's knock it out. FTC part 1. Okay, and it's basic. This is just saying how you take the derivative of an integral. Now, I'm going to remind us what we had up here. We had the derivative, and you can jot this down again if you'd like. It won't hurt to remind yourself what part 1 is. Part 1 of the fundamental theorem says if we take the derivative of the integral from a to x of some function that has a different variable for the argument, this simply gives me f of x. Now, I'm going to add one additional piece to this. If the derivative of this upper bound were included, and I know it's weird that we're thinking about it, but if the derivative of the upper bound were included somehow in this calculation, I would then multiply this by, what is the derivative there? Careful, the upper bound. And we'll see where this comes from. If we had it, what would this derivative be? X prime. What are we taking the derivative with respect to? X. So what's the derivative of x? Would we ever know if there was really and truly a 1 hiding here? We can't tell. I can put it there and it doesn't change anything. With that, we're going to keep that in mind for just a moment. And we're going to see that this is going to work out awesomely. I'm going to come back to this question. I know it seems out of nowhere. It is out of nowhere. Let's see if it connects. Let's do a couple of these. Okay. I want us to find the derivative. Find the derivative of the integral from negative pi to x of, let's say we have a function, the cosine of t dt. Okay. Some of you may be comfortable applying this theorem in its true nature right now. I'm going to just check. You don't have to write it down, but 10 seconds from now, if you understand what this theorem is telling us, you're going to have an answer for me. Talk with your neighbors. Can you tell me what the derivative is within 10 seconds starting now? Okay, anybody confident that you can tell me the derivative? Rafa's claiming cosine of x times 1, but cosine x. So let's check. Now, if we're not quite sure how to apply this, that's okay. We just saw this theorem yesterday. We haven't done a single problem with it. Let's just take care of everything first. What do you think happens first? I'm going to put these on here just so we can see that, look, it's there. Is there a clear inside and outside? Should we deal with the inside first or the outside first if we're just following order of operation stuff? Probably the inside, right? We have a nest happening here, and I don't want to get too bogged down in that. But let's just pretend we have no idea how this works. And maybe we don't even have to pretend, which that's okay. Let's just work out this part here, and then afterward, we'll take the derivative. So I'm going to jot that down. Let's do the integral. Then differentiate it afterward. So we won't try to do it all in one big sweep. We'll do it in 2 small parts. Your first job is not even thinking about the derivative. With your neighbors, I want you to find me this integral. If you need to open up to 5.1 because you don't remember the antiderivative of cosine, that's okay. If you're not 100% confident, you better be checking though, because you're going to get the wrong answer if you're not. I want you guys to find me this integral. Much like the problem we did before, I'm about to give you guys a page number. It actually might be 4.8 now that I'm thinking about it. I'm getting there. You can find your best friend waiting for you on page 364. Cool. Anyway, here we go. I work these as follows, and I want you to work them using the same notation. Whether you work left or right is up to you. But the very first thing I'm going to do is, what's the integral? You know what? We're going to switch. Normally I ask what's the derivative or antiderivative of cosine, but antiderivative is a lot of syllables, and I get stumbled up on it. So we're just all going to agree. If only there was another word that told me to take the antiderivative of something. The integral. Moving forward, I may ask you what's the antiderivative. I might just ask you what's the integral. They're the same thing. Cool, cool? Okay, what's the integral of cosine t? Sine of t. And then what am I going to put next to this? Let's bar it. Negative pi. You're right, the plus c. I do appreciate that. Why aren't I writing plus c? Because it's going to fall out. Good catch. You were right. Okay, so let's do this. This becomes the sine of x minus the sine of what? Negative pi. Now, there's all sorts of fun things that we could do because we all remember very vividly that sine is an even or an odd function. Was that a guess? That was a perfect answer. Riley said right away, it's odd. Gosh, I feel so silly. What does it mean? If only we had an index and a glossary that would help us find answers. What does it mean for a function to be odd? This is not specific to this problem, but it seems like a natural chance to pick up some knowledge that we might have left behind somewhere. What does it mean for a function to be odd? I'm hoping it's in your index and glossary. We're about to find out. Odd function. We might have a scavenger hunt in our textbooks, just for fun. Have you guys found the page yet? Okay, so that's a very mathy definition that I love. I just want to show you guys, here I am. I've opened up odd is O, and here are the O's in my book. And where I just went to the index. Hey, look at that. Pages 10 and 11 is where we need to look. So that's like chapter P1 is my guess. An odd function. Read yours again, Fern. That's what I care about. That's that one part. This is what it means to be an odd function. Now, it does not apply to this problem specifically, but I sure it will. The fact that this has symmetry about the origin will wind up being incredibly important. If I plug in x, I get the same thing but negative if I plug in negative x. This is what it means to be odd, which means all of a sudden we could probably even sneak ahead. If I said this is an odd function, integrate from a to b, give me a number. I don't care what it is. What do you think this area is? You can just give me any number. Let me rephrase. You can give me any number with one more little tack on top. 12 does not. There we go. If that's negative 12 and this is an odd function, what would this be? 12. So if I said let's integrate an odd function from negative b to b, for example, what's it going to come out to be like every time? 0. Okay, we're going to keep that in our minds. We're going to see that again. This is a natural spot to bring it up. We could apply this here. We could say this is the same as plus the sine of pi is where this would show up if we're doing it. But maybe we don't need to. Point to pi with your hands. So I see opposite directions. We start at 0. We work clockwise or counterclockwise? Sorry, I'll go from your 0. No, that's your 0, isn't it? Yeah, I'm working to it. And we go counterclockwise until we get to pi. What's the sine of pi? 0. Okay, we just found that this integral is sine of x. Okay, nothing crazy so far, I hope. What haven't we done? Yeah, so now let's take the derivative. Now, d dx. And let's do it. d dx of the integral from negative pi to x of cosine of t dt equals the derivative we said of what new function did we just say this was? Sine x. What's the derivative of sine? Cosine x. Now check it out. We just made a huge jump. just like I was mentioning this yesterday, we had dealt with the derivative at a point where we take the limit of the difference quotient and we can get like, oh yeah, over and over we can get it. And then we said we can get the derivative as a function as well. Maybe if I wanted to find the area or how fast something's changing, and we'll connect all these, scratch what I said, I'm not going to expand on that one. I like cosine x. Now, Rafa, because you mentioned it, you had this right off the bat. Is there really, could I say times 1 if I wanted to? Now, the because I wanted to part makes this weird. I didn't have to do anything strange here. How do we feel about this first problem? Okay, I'm going to give you one more, and I'm even going to let you guys pick. Are we boarding or are we notebooking? It's a harder problem, just so you know. Notebook? Okay. I'm fine with it, but if I hear less thinking with this is going to be the last time you get the option for it. On B, we can do a more fun one. Love this one. How gross do we want it? Okay, that's probably the right answer. ddx. You were going to take for me the derivative of the integral from 2 to x squared of 2t plus 1 dt. Okay, I want you guys to work the same way that you guys work up on the boards. I want to be able to hear your discussion so that instead of just awkward silence, it's clear that the gears are turning for everybody. If you get B and you're confident with it, I'm going to give you one more. I'm going to give you a challenge. Oh, I can't even find any gross ones. We'll find a gross one. Why can't I find a gross one? I don't want it to be too terrible. Cool. Okay. ... When we get down to this, I saw several groups come to the following. You came to 4x cubed plus 2x. And I took away a lot of stuff out of this, just so you know. Okay, I have one more question for you that I want you to think about. I want you to try this one as we go. Notice, from a constant to a variable is what happened. Okay, now as we look at this, if I wanted to factor something out, could I factor something out of this? If I factor out a 2x, what would be left inside? 2x plus 1. My big question, I want you to try this one, but that talk back to me bringing up the 1 at the beginning over and over. I want to know, is there a shortcut that we could possibly take to get from here, all of this, through a shortcut of some type, down to this? Cool. I want to make one more change. Make this negative x to 2x. On C, I want you to try C over the weekend. If you need help, I'll be here after school for a minute. See you cool cats and kittens on Monday. Finish or at least attempt this problem. I'm going to hit save so I don't lose it. Cool, 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 cool. Adios. See you all at 3:30 to come and beat me at chess. Did you commit to OT? No? Did you commit anywhere yet? Tell me you want another shirt, and that now you wear extra large. CAL, see you later. We never addressed it. So it's a silly little game that I get a huge kick out of. Since I was little, if I'm eating dinner with somebody and you get up to go, like, right hand up, do you hold your fork in your right hand and drink with your left? So if you came back, if you got up to the bed, I thought you were saying it too, so I thought about it. Weird thing to say. Wow. If it was this desk, yeah. At dinner, like you're out at dinner and you come back and now your fork is on the left side of your plate and your drink is on. Can you do that? Well, on that one. It's something I've done since I was little. It's a super weird thing that I do, but people are way less efficient than me. Which I can do. Are you gonna tell them today? Or too late? Maybe. I've done it before. Like they all knew what the deal was. Mm-hmm. I remember being so embarrassed. I went to the AP training thing years ago, and the old book that we had never showed the shortcut for this. Like to just change it to X and take the derivative. Is what winds up happening. I guess on the first one. And I remember the realization of holy cow, I've been making kids spend so much more time on these than they really need to. Yeah. And I'm glad I went to the training. I'm just gonna end this video and up